Hi, I'm Kim Shepard. Today we're going to go over video 4C, where we're going to describe positions in a data set other than the center. We're going to look at something called quartiles and percentiles. Okay, previously we looked at this data set from some cycling data on strength. So we're going to look at this again. And last time we looked at the median in particular. The median was the value that split the data into two pieces. So half the data are below the median and half the data are above the median. So that was sort of a measure of position. Today we're also going to look at some positions or some measures of position where we split the data into 4 quarters, and these values are called quartiles. The first quartile we denote with a capital Q with a subscript of 1, and Q1 is the value that separates the bottom 25% of the data from the top 75%. The second quartile we've actually already talked about. The second quartile is the median. It splits the data in half, separates the bottom half of the data from the top half. And then finally, the third quartile, we denote Q3, is the value that separates the bottom 75% of the data from the top 25%. Typically, we'll be using StatCrunch to compute quartiles, but today we'll look and see how we can sort of think about these, and typically you can visually find them with a smaller set of data. One question I'm often asked is, if it's quartiles, there's 4 quarters in a dollar, how come there weren't 4 quartiles? There were only 3. So if we draw out some data, let's say this is the smallest observation in your data set. This is the largest observation. We know about the median. The median is a value that splits your data in half. We also now know that's the second quartile. And we just learned that Q1, the first quartile, is the value that separates the bottom 25% of the data from the top 50%. It also cuts the bottom half of your data in half. And Q3, the third quartile, separates the top half of your data in half. There's only 3 quartiles, but they separate the data up into 4 equal parts where you have 25% of the data in each part here. So Q1 again separates the bottom 25% from the top 75%. We know about the median, and Q3 separates the bottom 75% of the data from the top 25%. Okay, so let's look at the quartiles for the cycling data set. The easiest one's probably the median. We've talked about that already. This data set has 14 observations, an even number of observations. The middle is sort of right after the 187. And so since we had 2 observations in the middle, we took the average of these to find the median. And half of our data are below 189, and half of our data are above 189. Now let's look at Q1 and Q3. Q1 separates the bottom half of the data in half. And so if we look at just the bottom half of the data, the top row, the number that sits right in the middle there is 180. And so half of the data are below that value, half of the data are above that value in the bottom half of the data. So 180 would be the value of Q1. Similarly, the third quartile cuts the top half of the data in half. And if we look at the top half of the data, 205 is the value in the middle. So 205 would be the third quartile. In addition to quartiles, we can also split up our data into 100 chunks. If we do that, those values are called percentiles. You've probably heard of percentiles before. Often if you're given like standardized test scores, you might find out this was your score, but you also scored in such and such a percentile. We're not going to talk about the formula for percentiles, but I'll draw up a picture of what they look like, and mostly we care that you understand how to interpret those. So if this was the smallest value in a data set, we could start to look at our data. The first percentile, if that was here, that would mean that 1% of the data would fall below that value. And the other 99% would fall above that value. If we looked at the second percentile, 2% of the data would fall below that, the other 98% would fall above that. And we could continue this on out forever here. Q1 is the 25th percentile. 25% of the values are below that, and the other 75% are above. So this would go on until we reach our largest observation. Let's look at interpreting some percentiles to make sure we have a clear understanding of what they mean. So here's a common place where you'll see them. You take the SAT. They give you your score. In addition to your score, they tell you that you scored in the 22nd percentile on your math score. So what this tells you is where your score was relative to everyone else that took the math SAT. So if these were all the math SAT scores, this was the lowest score, this was the highest score. You scored in the 22nd percentile. I'm going to approximate that to be about here. 22% of the people that took the SAT had scores lower than you, and the other 78% of people had scores higher than you. And so up here you have the 78% that had scores higher than you. Quartiles and percentiles are nice. They're measures of position, so they let you know, was my score a good one when I took the SAT? This sort of lets you know relative to everyone else where your score was. All right, let's look at another one. Okay, suppose on some type of, this is still your SAT. On your SAT, you scored in the 3rd quartile for your English score. So how did I do on my English score? Again, if these are all the scores, if you scored in the 3rd quartile, you were up here. Q3 is also the 75th percentile. So 75% of the students had a lower score than you did on your English SAT, and 25% would have had a score higher than you. So 75% were below, and 25% were above. All right, one last example with percentiles. Professor Koop remembers working with a guy whose wife had a baby, and he proudly announces that his baby's skull was in the 98th percentile. So what does that mean? His poor wife. That skull was larger than 98% of all other babies that were born at whatever term he happened to be born at there. So that meant that that baby had a fairly large head there. Only 2% of the babies had skulls that were larger than that. And if you have kids, when you go to the doctor and they measure their height at a certain age, they'll show you growth charts, and they'll often give you percentiles. I have a tall and skinny child, so she's always in the 25th percentile for weight and like the 75th percentile for height. So 25% of the people weigh less than her, and for height, 75% of the people are shorter than her. So that's it today for quartiles and percentiles.